All right, let's see how this goes. I want to talk about graphing systems, graphing as a method to solve systems. A system of equations is nothing more than a collection of equations. In problem number 11 of your homework, I have equation number 1 and equation number 2. The system has a common solution by finding the point that is a point on each one of these lines. So I'm going to graph both of them and look for the point of intersection. You need to be very accurate in your graphing, which is not as easy as I'd like it to be in the technology I'm using, but please use graph paper to do this. All right, equation number, the first one in number 11, it's in the form y equals mx plus b. The b value is 7. That's on the y-axis. That's where you will begin, b for begin. The slope of this line, m, is 1/2. That's how you will move, m for move, and the numerator is the vertical change and the denominator is the horizontal change. So to graph this, and I'm going to try to be careful, but it's not that easy in this technology, but I will begin at 7 in the y-axis, so it is there. From there, I will go up 1 and over 2. I will go up 1 and over 2. It does not like me to make big dots, so these aren't even very good dots. I can reverse it and go down 1, left 2. And what I'm trying to get, you can do it with just do the B, use the M to go up 1 over 2. You've got 2 points. I did extra points to give myself an opportunity to have maybe a straight line. And that is just very close to impossible using OneNote, but that's what I'm doing. You can't see me doing this, but I'm trying real hard to use a straight edge and draw that line, and you can see it did not go well. That's a terrible line. In fact, it's so terrible that I'm going to erase it and try one more time. Let's see if I can freehand a line. Not very well. Okay, you should be using a grid and a straight edge, and you should have a beautiful, perfect line. Using a straight edge while I'm doing this video recording just doesn't work, and I'm sorry about that. All right, this second one I'm going to do in red, or at least I'm going to give it a try. All right, so for this one, the b value is 3, and the slope is 3 over 2, which means up 3 over 2 from your beginning point of 3. So I will begin at 3. From there, I will go up 1, 2, 3 blocks over 2 blocks. I get a point there. I will do it again, up 1, 2, 3 over 1, 2, and get there. And I'm very happy because just in doing that, I was able to find the intersection of these two lines. Now that doesn't always happen. Sometimes you won't land on it, and you have to just be super careful with your graphing. The solution to the system is the point on the grid that is a solution to each of them, to both of them. So it is that point of intersection. So the solution is the point 4, 9. Now you could check it. I'm not going to take our time to check it, but you could put 9 in for y and 4 in for x in this first equation, y equals 1/2 x plus 7, and it should be true. You could then put it in the second equation, y equals 3/2 x plus 3, and it should be true. And it's the only point in the entire coordinate plane that is true for both. So the key to this is having accurate graphs for each of your lines. In a minute or in another video, I will do one where the lines do not start out in this beautiful y equals mx plus b format, and you have to modify it. All right, I'm skipping over number 13 because hopefully you could do that one. They are in slope-intercept form. The second equation has a y-intercept at 0, so watch out for that. All right, number 15, neither equation is in slope-intercept form, but I know in some of your previous assignments you've had to modify things to get them in slope-intercept form. So what I'm going to do to the first equation is solve it for y. The first thing I'm going to do is subtract 4x from both sides. That gives me negative y is equal to negative 4x minus 1. The coefficient of y is negative 1, so I will divide everything by negative 1. And I get y is equal to positive 4x plus 1. That means that my b value is 1 on the y-axis. Don't forget that, always. The b value is on the y-axis. The slope is 4. It needs a denominator, so it's 4 over 1. That's up 4, right 1. The second equation, I need to solve it for y. So the first thing I'm going to do is add x to both sides. That gives me y is equal to 1x plus 1x is 2x minus 5, and I'm done. And the b value is negative 5, remember, on the y-axis. And the slope is 2. You need a denominator, put it over 1. That's up to right 1. Okay, so let me enlarge this grid. All right, let's see if I can do the first one. I believe I will do it in blue. All right, I begin at 1. I will move up 4, 1, 2, 3, 4 over 1, and I drop another point. I'm going to repeat that. You don't have to, but I want as close as I can to getting a straight line. Up 1, 2, 3, 4 over 1. If you want to, you can go reverse, down 1, 2, 3, 4, left 1. All right. Once again, I'm doing what I would not want my students to do. I'm trying to sort of hand draw this, and I'm, not doing a very good job. So I would never recommend you trying to hand draw this, but putting a line on here just is not working. Let me see one thing. Okay, I'd hoped I could just insert a line where I needed it, but that's not working for me. So let's now go to the second one, and the y-intercept is at negative 5, so I will begin at negative 5. I will go up to right 1, up to right 1, up to right 1. Now these two lines are diverging. If I went down to left 1, down to, left 1. All right, my red line is doing this. Okay. So they're going to intersect somewhere in this quadrant. So I need to go back to my blue line, and this is where it would be so much easier if I could just draw these lines and continue with that reverse process of down 1, 2, 3, 4, left 1, down 1, 2, 3, 4, left 1. It looks like that if I continued this one and I went just a tiny bit more with my red one. If I went down to left 1, that they would intersect, and it's off the grid that I have, and I'm sorry, that's not good, but it looks like, and I will check this, it looks like the intersection is right here. It's off the grid I have, and I am restricted to the amount of space that I have with the tools that I'm using. All right, so it looks like the solution is -3, -11. -3, -11. Now, because I had to go off the grid and it was kind of hard to see what was happening, I'm going to actually test it. All right, I'm going to check it in the first one. It is y equals 4x plus 1. -11 is the y, is equal to 4 times -3 plus 1. I'm taking these values for x and y and I'm checking them. So is -11 equal to -12 plus 1? And yes, it is. So it is checking in the first one. Let's look at the second one. I have y equals 2x minus 5. So I have -11 is equal to 2 times -3 minus 5. Is -11 the same as -6 minus 5? Yes, it is. This is how you would check. It's not usually required in a problem, although your instructions do say check your solution. This is how you would check it. But a piece of graph paper for the problem would be so important, and you could actually use your line with just a few points, use a straight edge with just a few points and line it up. Every time I try to do a straight edge with this floating screen that I have, it does not hold for me. So let's see if I can pick out something else. All right, let's take a look at problem number 17 and see if it offers anything different. If I'm supposed to solve this system, well, these lines are not in slope-intercept form. Please remember that in graphing, y equals mx plus b is your best friend. It's not your only friend, it's your best friend though. So I want to solve each of these for y. For the first one, I'll subtract 2x from both sides. That leaves me with -y is equal to -2x minus 5. I want to divide everything by -1 because the coefficient of y is -1. That gives me positive y is equal to positive 2x and plus 5. The b on the y-axis is 5. The m, which is the slope, how you move, is 2 over 1. It's 2. Put it over 1. You've got to have a denominator. That's up to right 1. The second line, you're going to add 2x to both sides, and you get -y is equal to 2x minus 1. Divide by -1 because the coefficient of y is a negative. That will give you positive y is equal to -2x plus 1. All right, let's see if I can move this to get the grid. Here's the grid. Let's make it, whoa, not that big. All right, the first one, I will do it with blue. I begin at 5 up 2 over 1. Begin at 5 up 2 and over 1. There's a point. Up 2 over 1. Or down 2, left 1. Down 2, left 1. Remember, all you would have to do is lay a straight edge on here and you could draw a beautiful line. I keep saying I'm having a problem with that. And so mine, I am hand connecting these. That is a terrible method. Don't do that. But that's your blue line. Your second one, let's see, I didn't finish this. The B value is 1 on the y-axis. The slope is -2. Now, I'm not sure if I've said this before, but when the slope is negative, and if you need to put it over 1, that means you go down in the vertical direction, but you still go right in the horizontal direction. Let me have a little aside here. If you had a problem that when you saw M, it was -3/4, I would attach the negative to the 3 and then leave the 4 positive, which would tell you to go down 3, right 4. Remember that a negative fraction does not have a negative numerator and denominator, just either the top or the bottom is negative, and I typically choose the top. So that was an aside. It really doesn't have to do with our problem. So let me grab my red ink. All right, we are going to begin at 1. And from there we go down 2, but we go right 1. Down 2, right 1. I'm going to reverse them, which is up 2, left 1. Up 2, left 1. So I was lucky. It pretty clearly crossed that line. So I have a point of intersection. Not exactly there. Let me put it here. Right there. So the solution is -1, 3. Make sure that you're careful in labeling the point of intersection. It is sad when I see a student that does all this work correctly, but then when they see that point, they label it wrong. But it is, the x is -1 and the y is +3. You could check it by plugging in this x and this y in first this equation and then this equation. And if they are each true, then you have a solution. All right, let me see about the word problems. All right, I may not do the graphing on the 2 word problems, the 19 and 21, but maybe I can help you set them up. The most important thing you do when you read through it is decide what X and Y will stand for. So I already have that written down, but if I read through it, it says the number of right-handed students in a mathematics class is 9 times the number of left-handed students. The total number of students in the class is 30. How many right-handed students are in the class? How many left-handed students are in the class? Now, the 2 unknowns are the number of right-handed and left-handed students. It does not matter which one you call X and which one you call Y. It doesn't matter. You might happen upon doing it that's an easy way or a harder way, but it's totally your choice. So I let Y be the number of right-handed, X be the number of left-handed. Now I write the system based on using these 2 unknowns. Okay, the 2 statements it has. The number of right-handed students, well, I'm going to write down Y, is, or in the math class is your equal sign, 9 times, all right, I'm going to multiply 9 times the number of left-handed students, which was X. That's my first statement. It gives me my first equation. The second statement says the total number of students in the class is 30. Total means the sum. So X plus Y is 30. You could have done Y plus X is 30. It doesn't matter. That is your system. And so I would take Y equals 9X. Remember that it is plus an implied 0. You would begin at 0. The slope is 9, which is 9 over 1. The second equation, X plus Y is 30. I'm going to subtract 30. Subtract x from both sides, and y is equal to negative x plus 30. The y-intercept, the b, is 30, and the slope is, there is an invisible negative 1 there. It's negative 1 over 1, which is down 1, right 1. This one was up 9, right 1. This is not a great problem to do by graphing because of the size of these numbers, especially this y-intercept of 30. Nevertheless, the only technique taught in this lesson is graphing. So you need to put a grid on an entire sheet of graph paper, making sure that your y-axis extends up to 30. And you will get values for x and y, and the x value will be the number of left-handed, the y value will be the number of right-handed. So I'm not going to graph that because I don't have access to a grid of that magnitude. So I'm going to try to just make that go away. So let's look at number 21. I think it's a little bit more of a challenging problem. Okay, reading through it. At a local fitness center, members pay $20 membership fee and $3 for each aerobics class. Non-members pay $5 for each aerobics class. For what number of aerobics classes will the cost for the members and the non-members be the same? The two things you're looking for are cost of the class, and I'm just going to call it X. Maybe I wish I'd called it not Y, I'm not sure. And the other thing is the cost for the members. It is the total, oh, no, this is not cost of the class. This is number of classes, and I kept misreading that. For what number of aerobics classes? It is the number, not the cost. You know the cost. The costs are $3 and $5. So this is the number of these aerobic classes. Y is the cost for members / non-members. Okay. Now, because it wants to know when they're the same would be a point of intersection. So let's look at what's going on for the members. The cost, Y, is they pay $20 plus $3 for each class, so each of those. The non-members, their cost, which is Y, they don't have a membership fee, but they pay $5 per class, or not per, but $5 for each class. So these are your two. I would rewrite this one as Y equals 3x plus 20. So we have B is 20, a big piece of graph paper, and M is 3 over 1. Y equals 5x, the B is 0, and the M is 5, or 5 over 1. And it says, for what number of aerobic classes will they be the same? And the question actually is only asking for X. You will get an X and a Y. X will be the number of classes. Y will be what that cost is, but it doesn't ask what that cost is. So I don't know how picky they are, but when you find your point of intersection for these two, the question is answered with the X value only. Okay, I hope this helps. One last thing I want to say. I'm going to get rid of this, maybe. And this did not seem to occur in your lesson, and I thought it would, and I looked at the problems. I know I skipped a couple, but I looked at them. When you graph a system, I'm going to switch, let me get some red. You can have intersecting lines, and that's your solution. And when you have that, because you have a solution, they are consistent. These are just descriptive words. That's all. They are consistent, and they are independent because they are different lines. Consistent means has a solution. Independent means they are different lines. Now, you might also get, let me see, and it didn't happen, but you might also get two lines that are actually the same line when you graph them. They might have been disguised a little bit, but they're really the same line. Now, there is a solution. The solution is infinite. Where do they intersect? At all their points. So there are infinite solutions. This one had just an x comma y. It is consistent because there is at least one solution, but these are dependent because they are the same line. And then finally, you can have two lines that when you graph them, whoops, I'm sorry, let me get my ink. You may not realize it when you start, but they turn out to be parallel lines. That means you have no solution. When you have no solution, it's called inconsistent. This is all spelled out in your book. I think it's on page 360. I can't read that last number. And on the next page, there are similar drawings. This is inconsistent, but these are not the same line, so it's independent. So I didn't write those all out. My personal opinion is that these labels are not all that important. Recognizing that one of three different scenarios can happen is important. But your book and your teacher may feel very differently, and she may want you to label these at some point. Remember, if there is any kind of a solution, it is consistent. If the two lines are, if you have different lines, they are independent. If you have the same line, they are dependent. And if you have, I should have written it up here, if you have no solution, it is inconsistent. And your teacher will let you know, I suppose, how important it is that you be able to categorize these. And that's all it does, is it categorizes them. But one of these three different things can happen when you solve a system. All right, I hope that helps. Take care.